Hello everyone, I'm Yuning Su, a second-year PhD student from Simon Fraser University, advised by Xing-Dong. I'm excited to share with you about Tagnoo. Tagnoo is a computational plywood augmented with RFID tags, enabling woodworkers to effortlessly create room-scale smart environment without requiring technical expertise, seamlessly integrating computational capabilities into plywood. Why do we need a room-scale smart environment? Human activities can diverse and occur throughout an entire space. In a home or office, activities aren't confined into a small area, but spread across rooms. To accurately capture this range of movement and activity, a room-scale smart environment is essential. For example, in homes, especially for elderly and disabled individuals, room-scale monitoring can quickly detect accidents like falls or emergencies, enabling prompt response. Continuous monitoring in a living space can provide invaluable data for healthcare providers. This includes tracking the daily activities, ensuring medication adherence, and early detection of deviation in routines that might indicate health issues. Our vision seeks to seamlessly combine sensing, computing, and wireless connectivity into materials used to construct the physical environment, thus enabling the creation of smart environments on an unprecedented scale. By imbuing computational and sensing capabilities into the very fabric of our surroundings, physical environments can actively sense and respond to users' activities, opening up a wide range of data-driven applications that can facilitate various life and work goals. But how to achieve room-scale smart environment? Current ad hoc solution, for example, ElectriSense, installed sensors on power outlets, utilizing electromagnetic interference in power lines to identify appliance. Similarly, Wall++ utilizes painted antennas and sensors on walls to capture airborne EMI signals, enabling the detection and localization of appliance. However, it is worth noting that the integration of sensors into existing spaces through current ad hoc methods often results in devices that are visually conspicuous and do not seamlessly blend with the surroundings. While this lack of integration can be mitigated by concealing the sensors more effectively within the environment, this process typically requires expertise in electronics and engineering, thereby posing challenges for woodworkers without a technical background. Consequently, the computational plywood could revolutionize the creation of smart environments, offering a scalable solution. By empowering woodworkers to effortlessly create room-scale smart environments. What is computational plywood? It should be equipped with sensing, computing, and wireless connectivity capabilities. It also should be fully compatible with standard woodworking practices, including sawing, nailing, and screwing. It preserves the natural appearance of conventional plywood. It enables woodworkers to create room-scale smart environments without specialized technical knowledge. It operates battery-free. Considering existing research, our work introduces Tagnoo, a new method aiming to create computational plywood that effectively addresses these limitations. Tagnoo is a plywood panel embedded with a matrix of RFID tags. This unique configuration not only allows for sensing, computing, and wireless connectivity capabilities, but also retains the inherent characteristics of traditional plywood. Each RFID tag works as a sensor. These sensors allow Tagnoo to detect the environmental changes by sensing disruptions or variations in RF signals due to the presence of objects or people. The fabrication process of the Tagnoo panels involves a four-step procedure. First, a unique ID was assigned to the first half of the EPC for each tag using a handheld RFID writer. The tag ID demonstrates the tag's density and the sequence number in the material. The remaining bits within the EPC were reserved for potential future item assignments. Next, the RFID tags were attached to a plywood substrate. The alignment of these tags was executed in accordance with the desired density. Following our gluing strategy, a thick veneer layer was firmly affixed on the top of the tags. The glue was then left to dry for a period of 24 hours. Finally, to provide a protective and a visually appealing finish, a layer of water-based finish was applied onto the surface of the panel. Here we demonstrate how to facilitate the creation of smart environments using Tagnoo. Begin by sizing Tagnoo appropriately, then smoothing its edges. After making and drilling pilot holes at the designated spots, secure the pieces together with screws. Here is an illustration of typical days for a Tagnoo user. For instance, the desk and the chair can detect and record events such as laptop usage durations and idle times. The information collected can be used to provide insights into the work practices, facilitating the personal reflection, and potentially even offer insights into the psychological state during work. In addition, the bookshelf can detect and log reading habits by tracking when the user takes the book from the shelf and returns them. If this routine is disrupted, especially during a busy week before a project deadline, the change in behavior can be logged for the user to review later. The desk can also detect the placement of objects such as a glass lunchbox with or without rice dishes. And the chocolate bar. This information can be used to infer details about diet. The floor can recognize standing, sitting, and lying on it. When combined with the duration of floor sitting exercise routine sensed by the floor, the system can provide insights into health, well-being, and lifestyle choices. Thank you, everyone. For more details and experiments, please see our paper.